Okay, so today we are going to look at graphing quadratic equations. Okay, so by the end of the period, we'll know how to graph a quadratic equation, at least sketch the graph of a quadratic equation. Yes, Najee? No. Okay, so let's just kind of step back. Let's put ourselves mentally back into the fall semester, right? And we learned how to graph y equals mx plus b. What type of shape will that be on the graph? It's a line. It's a line, yes. It's a straight line. Okay? So y equals mx plus b is a straight line. For instance, if we had y equals 1/3 x plus 2, how would we graph that? Start at 2.
You go up 1, right 3.
Good. Up 1 and over 3, and we get another point, and there's our line. Okay? So by looking at this equation, I know immediately it's a straight line. I know where it crosses the y-axis, right? I know that the straight line continues forever. That's why these arrows are here. It's going to continue forever. Okay? Today, we're going to look at equations in the form of y equals ax squared plus bx plus c. Now, this is a quadratic equation. This is a quadratic equation. Now, this is not the first time that we've seen quadratic equations because we factored them before. Right? Remember we factored and they were quadratic equations? Okay. Now, the shape of a quadratic equation, when I graph it, looks like, anybody know?
A U, ain't it?
A U. It looks like a parabola. It's called a parabola. It looks like a U. Okay. I like to say that it looks like a bowl because this is a really cool word and it's one of my favorite math words. Parabola. Parabola. Yeah, you can make it any language you want. Parabola, parabola, parabola. Okay. Bola, bola. That makes me think bowl. Okay. Parabola. It makes me think bowl. Anybody know how to say bowl in Spanish? How do you say bowl in Spanish?
I'm thinking.
Then we're slow.
That's a word.
Right.
You never learned that.
When
You never
you're
said I
asked-
want a
when
bowl
you're
of
asked,
cereal.
it's like you forget. You just say you want cereal. You never say you want a bowl. It's just there's some words that you don't really use.
You don't use in the other languages.
You say, no, it doesn't sound like that, but it's like casa.
Yeah. Oh, okay.
Casa.
It's that container or something, right? Vasa. Yeah. Okay. So anyway, we're gonna pretend that bola means bowl. Okay. Do you ever pretend that you could speak a language when you're little? I used to do that. I always wanted to be able to speak another language fluently, and I can't. I like languages. I should have studied that in college. Like we used to walk around the mall. Okay, you're gonna laugh at me. We'd pretend that we were speaking another language, like being all cool.
I want to learn how to speak Arabic.
Yeah. And then my language would like switch in the middle, like I was so cool, you know. Anyway, yeah. That was my entertainment when I was a kid, walk through the mall acting like I could speak languages. Okay. Anyway, we're going to pretend that parabola means bowl, right? Bola, right? So that's how I remember that it's a parabola. okay, because bola, all right? So let's talk about well, first off, how do I know? Well, if I look at this equation, the thing that is significantly different about this equation and that equation is that I have an x squared. Okay, that's a significant difference. If that wasn't there, right, if this was not here, it would look like a line. Bx plus c, that's the same thing as mx plus b. It would be a line. But because I have that x squared, I know it's a parabola. Notice that the y is not squared. If the y was squared, it would be a circle, not a parabola. And we're going to learn about those later. Yes?
How do you make it a C shape? Like sideways?
Sideways, that would be if it was x equals ay squared plus by plus c, which we will not be doing in this course. Okay? Depends on what course you take.
Miss Murray,
Yes.
what's that other math course on the?
Yeah, what is math and
Data and
Yeah.
finance.
Okay. So that course is yeah, that's it's a mixture of things. It's got some algebra, just some regular math. You're going to talk about taxes. You're going to talk about investments. You're going to talk about checking accounts. You're going to talk about credit cards.
Oh, so it's like a
It's financial math.
So is that okay for our last math course? Because they put me in that.
that's a smart class.
Honestly, like that actually sounds like something on YouTube. Is that what we take now?
So we recognize. Come on, guys, we got work to do here. Come on. We recognize a quadratic equation because the x is squared, and as soon as we see that, we know we're talking about a parabola. So now let's look at some of the features of a parabola, right? A line, we know, is just straight. A line has what we call a constant rate of change. It stays the same. It's changing, right? So a line, let me just give you an example here, right? So here's a straight line. Let's just pretend that this is a distance time graph. A straight line means that I'm covering a consistent distance. So every hour, let's say every hour I'm going 10 miles, right? Every hour I'm going another 10 miles. It's constant. It's the same rate of change of 10 miles per hour, right? That's what a linear equation tells us, that it's a constant rate of change. I'm changing my speed 10 miles per hour. It's constant, okay? A parabola represents something that's not constant, okay? We get that shape that looks like this. Whoops, that's a really bad one. It's very hard to draw them on here, by the way. Sorry. Oh my goodness. Let's try again. Okay. That's better. Okay. We've got that U shape. Now here's some key parts of the parabola that we must know. Okay. The first part is this line here, which is not actually part of the graph. This is what we call the axis of symmetry, because a parabola is symmetric. What does symmetric mean? Same on both sides, right? It's symmetric. Our faces are symmetric. Our whole body is symmetric, right? If you were to slice me in half, please don't try. But if you were to slice me in half, you'd have hopefully, exactly the same sides, okay? It's symmetric. A parabola is symmetric. So if we were to take our paper and fold it over on this line, this orange line, the two green halves would match up exactly, okay? That's called symmetry. And that line that we folded over on, that's called the axis of symmetry. Okay? This point down here, this is what we call the vertex. We hear that word vertex in reference to other shapes also, and it usually refers to where the shape changes direction. Okay, did I start the video again? Yeah. Okay, that's what we call the vertex. All right, so let's just start looking at some of the graphs here. Okay. Please take notes. This is very important that you take notes. Okay. This graph here that we're looking at is the line y equals x squared. Okay. That doesn't look exactly like this, does it? Ax squared plus bx plus c. But I know it's a parabola because the x is squared and the y is not squared. Just in this particular case, the b is equal to 0 and the c is equal to 0. But it's a parabola. Okay, that's what we call our base function. That's our base function. Okay, the base function has a vertex at 0, 0. The vertex is 0, 0, right there at the origin. That's our vertex, okay? Okay, so let's look at this. What if, okay, let's go back to when we were graphing absolute value equations. What if I wanted to graph the line y equals x squared plus 2? What would that do to my base function? Move it up 2 units. Yeah, we did this when we graphed absolute values, okay? We take that function and we move it up 2 units. So now my parabola is up here. What's the vertex of that parabola? Okay, the vertex is a point, so it's 0, 2. Yes, the vertex is 0, 2. Okay. Did the axis of symmetry change? No. Okay. Okay. What if I graph the line y equals x minus 2 in parentheses squared? Does anyone remember what happens with that? To the right. To the right. This is going to, so when we're adding or subtracting inside the function, inside the parentheses, we're shifting left and right. Remember when we did the absolute value equations? We're shifting left and right. And it's always the opposite of that. Later on, you'll learn why. But for now, just know that it's the opposite. So since this is negative 2, it's going to move 2 to the right. So it's going to do that. Okay. Now let's just take a minute to look at a couple features about this one. Yes, ma'am.
If it's positive, does it go to the left?
Yes, it does. Okay. Okay, so what is the vertex of that parabola?
2, 0.
2, 0. Very good. So the vertex is 2, 0. Okay, what's the axis of symmetry? So there's my axis of symmetry, right? Because that's where it's cutting it in half. Okay, so here's what we're going to do. We need to give this a name or give this some way of describing it. Okay, and it's going to be an equation. So what value is it going through there? 2. Is that an x or a y? It's an x. Your axis of symmetry will always be x equals some number. And in this case, it is 2. That's my axis of symmetry, and I've identified my vertex.
That's your answer.
For now, yes, we're baby steps here, right? So let's look at another one. Let's look at the equation y equals x plus 3 squared. I want you to tell me my vertex, the axis of symmetry, and then sketch it. Okay. So what's the vertex? Maybe it would help if you sketch it first, right? So we're going to move it which direction? Left 3. 1, 2, 3. So there's my sketch. And I'm saying sketch because we're not really drawing a real accurate graph yet. So there's my sketch. So what's the vertex? -3, 0. Bless you. What's my axis of symmetry? X, you're right, X. X equals -3. Notice, by the way, that the axis of symmetry is always this value right here. That's my axis of symmetry. Always. Okay? Okay, here's another one. This one's a little bit harder. Y equals x plus 2 squared minus 3. So let's go ahead and sketch it on our graph first. What's the plus 2 going to do? Left 2. And what's the minus 3? No? Down 3. When it's inside the parenthesis, it's left or right. When it's outside, it's up or down. Okay.
Negative for this one.
Yes. Okay. When it's inside the parenthesis, it's the opposite of what's there. When it's outside the parenthesis, it's the same. Yes, Ava.
So since it goes to the left and it goes down 3, is it -2, -3?
Yes, that is correct.
Is that where the vertex goes?
Yes. So here's my vertex, and I'm just sketching the parabola. Make sure that when you sketch it, that you're giving it a curve. It is not a V. Because what's a V? What type of graph is that? Absolute value. That's your absolute value. Make sure that you're giving it that curve. Okay. As good as you can make it. Okay, here's my axis of symmetry. Okay, so what's my vertex? -2, -3. And my axis of symmetry, x equals -2. Make sure you specify x equals. Okay, don't just say -2, okay? Because it's an imaginary line. It's not just a number. Yes?
So when we sketch it, we don't have to pass the line. Like we don't.
For now, no. We'll get there where you do have to. Okay? Okay. There's a worksheet in Google Classroom. There's only 4 problems. I would like you to do those. I'm just going to give you a few minutes to do it. We're not finished, so please don't put all your stuff away. You're going to do these 4 problems, and then we're going to move on. It's called vertex form. Worksheet says vertex form. Okay, so, except that I just lost my pen. Okay, so this one, what's the vertex on this one? 3, -4, right. And the axis of symmetry is x equals 3. Make sure that you say x equals, okay? So we've got the point 3, negative 4 right here. And there's my sketch of the curve.
How
Yeah.
come the 3's not negative?
We do the opposite of what this is. Okay?
Do we have to put the line back there?
No. Not right now, you don't. Okay, the next one, number 2. What's the axis of symmetry? The axis of symmetry. Good. X equals 4, and the vertex is 4, 1. These shouldn't take long at all, guys, right? This is like so simple. My first grader could probably do it. Okay, maybe not first grade, but it's pretty simple. Next one. Michael, what's the vertex? What's the axis of symmetry? Almost. How about negative 2? We do the opposite of what's there. Negative 2, 2. Okay. I am going to just make a flat out statement, right? If you are not getting this at this point, that's because you are not listening. Because this really is simple, guys. This is simple. We have said at least 10 times today that it's the opposite of that number. If you're not getting it, you're not listening. And if you're not listening, good luck to you because it's going to get harder. Okay? You need to be listening. I know you can all do this. This is simple. All right? So stop daydreaming or doing whatever else it is that you're doing. All right? Let me see here. Nico, what's the vertex? 4, negative 2. Excellent. Wyatt, what's the axis of symmetry?
X equals 4.
Okay, Wyatt, did you finish and upload your worksheet?
Yeah.
Okay. So we've got the point 4, negative 2. There's my parabola. We just finished all 4 problems in about 3 minutes. Okay? Simple, right? Simple, 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 simple. Okay, let's go back. What do you think would happen? Let me just go back up to, let me just draw a basic y equals x squared again. Right. Here's y equals x squared. That's my basic y equals x squared. What do you think would happen if it was y equals negative x squared? Upside down. Yeah, upside down. Okay. So what if I had okay, let's do our y equals x minus 4 squared plus 1. Okay. What's the vertex of that parabola? What's the vertex? 4, 1. Okay. 1, 2, 3, 4, 1. There's my vertex. Right, here's my axis of symmetry. Graph it. Great. Okay. Well, what if I had y equals negative x minus 4 squared plus 1? What's going to happen? Upside down. What's the vertex of that parabola? Same thing. Yeah. The axis of symmetry and the vertex are the same. Okay. The advantage of this vertex form, okay, I taught it to you this way because if I started off by just giving you the equation x minus h squared plus k, that tends to confuse everyone. This is what we call the vertex form of the equation. right? And you throw those H's and K's in there and everyone gets all upset, okay? But this is the vertex form. That's what we've been working with, right? Here's my H, here's my K. The advantage of this form of the equation is that we can easily see the vertex. Now, when we're using this and we're describing real life things, okay, application to the real world, parabolas would describe some type of motion. For instance, let's say that I'm firing a cannonball or some sort of projectile, right? It has what we call a parabolic path. The vertex is going to give me the maximum height of that path, of that projectile path. This is its application to the real world. Okay, this is one example of its application. Okay, so that vertex is very important because it helps me identify the maximum, or if it's something that's going down like this, the minimum value. Okay, well, the other form that we're going to look at today is what we call the standard form. Everybody needs to write this down and everybody needs to pay attention. Okay, this is what we call the standard form. This form is a little harder to work with, but it gives us a little more information and we can get a better graph. Up until now, we've been sketching the graph because I don't know, based on the information I have, whether the graph looks like that or whether it looks like this. I'm not sure. And there's a significant difference. I mean, it could be a really fat parabola. I'm not sure based on the information I have. And it is important because the skinnier parabola means that it is changing faster. It has a faster rate of change. This fatter parabola means it's changing slower. Okay, its rate of change is changing slower. So that's very important to me, right? Put it in projectile terms. Is that going up like this and back down, right? Or is it stretched way out like this? Okay, that matters, and that's important information to us. The standard form is going to help us determine that, okay? So let's look at an example. I'll try and come up with some examples that don't have fractions involved. So let's do y equals x squared. Let's see here. Let's do plus 6x plus 8. Okay. So the first thing we're going to do is identify the A, B, and C. So what's A in this equation? 1. Good. Because there's an assumed 1 right here. What's B? And C? 8. Okay. So the first thing we're going to do is determine the y-intercept. Now, the y-intercept is an important point because the y-intercept is where x equals 0. And a lot of times when we're describing motion, it's the starting point. It's like the starting height. For instance, let's say that I was kicking a ball off the roof, right? It's the starting height of that ball. Okay, so that's why the y-intercept is important to us. So the y-intercept is actually the c value. So the y-intercept in this case is 8. That means it's going to cross the y-axis at 8.
So the y-intercept is always c?
Yes, when it's in this form. Sometimes you have to put it in that form, but we're not going to do that today. Okay, so there's my y-intercept. All right, the next thing we're going to do is find the axis of symmetry. And we're going to use a formula for this. Again, the vertex form is easy, but we don't get a whole lot of information other than the vertex, okay? The axis of symmetry is going to be x equals, remember I emphasized that up here. I said x equals, right? Axis of symmetry, x equals. We're going to use the formula negative b over 2a. We're going to use that formula. So, in this problem, what's b? 6. So it's going to be negative 6 over 2 times a, which is 1. So we get negative 6 over 2, which equals negative 3. So my axis of symmetry is x equals negative 3. In this case, it is important to actually sketch that axis in. Okay, so I'm going to use a dotted line to just remind me that this is not actually part of the graph. It's just something I'm going to use to graph. Okay, so that's my axis of symmetry. Okay, so we could easily see our y-intercept. We didn't have to do anything for that. We just look at the number that doesn't have an x. That's my y-intercept. And then we use that formula to find the axis of symmetry. Okay, now let me just go back to the other worksheet we did. Okay, look at this worksheet. Right, I have my axis of symmetry x equals negative 2. Now look at my vertex. The x is negative 2. Axis of symmetry, x equals 4. Look at the vertex. The x is 4, right? Axis of symmetry, x equals 3. The vertex, the x is 3. Do you see a pattern there? Maybe? Okay. I have my axis of symmetry. So the vertex is a point, right? The vertex is a point. What's the x portion of the vertex? Negative 3. Because my axis of symmetry is x equals negative 3. When you look at the parabola, that vertex is on the axis of symmetry. There's my axis of symmetry. There's my vertex. Okay, here's my axis of symmetry. Here's my vertex. Okay, the vertex is on the axis of symmetry. So we have the x value. How can we figure out the y value? Because I know my vertex is negative 3 something, but I don't know where it's going to be. So if I know x, how do I figure out what y equals? Nico? No, that's the y-intercept. Equation, yeah. Do me a favor. Read that for me. What's that say? Wait, y what? Y equals, right? I'm looking to figure out what y is. What does y equal? Well, there's my equation. It says y equals x squared plus 6x plus 8. I've got it right there. So in order to find y, I'm going to plug it in. X is negative 3, so negative 3 squared plus 6 times negative 3 plus 8. Okay, that's going to give me 9 minus 18 plus 8, which actually equals negative 1. So I knew my x value. Then I take the x and I plug it in to figure out the y. And y comes out to be -1. So now I have the x and the y. Now I know my vertex. Okay, so I've got the point -3, -1 is my vertex. Okay. Is the number in front of the x squared positive or negative?
Positive.
So is it opening up or down?
Yeah.
Up. Positive is up. Negative is down. Okay. Okay. Now here's the thing that's different. I'm not going to just sketch my graph now, right? Because I have enough information that I can get a better shape, right? Notice this point right here where it crosses the y-axis. How far away is that from this axis of symmetry? How about 3? It's 3 because this is -3 right here. It's 3 units away. So if I were to fold my paper over on that dotted line, I would get another point 3 units away from that axis of symmetry. So just envision folding it over, and I've got a point that matches the point that we had on the y-axis. That's another reason that point is important, because once I plot that point, I can use my axis of symmetry to find another point. I have 3 points. Now I can draw my parabola, and I've got a more defined shape to it. I know how quickly it rises. Okay? Let's go back over what we did. We've got A, B, and C. Based on the C, I figured out the y-intercept. Everybody with me? Najee, you with me? So you don't have to wait for Wyatt to do his worksheet before you can do your worksheet?
Yes, he was.
When he was doing that worksheet?
The large. Where you want it?
Okay. We've got the y-intercept. We've got the y-intercept. Patrick, you with me? You awake? We plot our y-intercept. The next thing we do is look for the axis of symmetry. This is a formula right here. This is a formula. We use that formula to find the axis of symmetry. And we got x equals -3. So I drew a little dotted line, x equals -3. Now I need the vertex. We already have the x part of it. We have to find the y part. So we plug the x in, and we get y equals -1. There's my vertex. Right there. Please stop.
And how did we get that first equation, y equals 1x squared plus 6x?
That's the equation I gave you to graph.
Okay, and we plug in the x.
Mm-hmm. Now we just plot the symmetry point, and we're done. Okay? Let's do another one. Let's see. Okay, y equals... Let's do y equals x squared. Let me see. Plus 8x plus 12. Okay, I'm trying to give you problems that don't have fractions right now. Okay. All right, we're going to graph this. Okay, I've got to leave myself enough room. I've got to make it kind of a big graph. Why is that? Well, looking at the equation, what do I know just by looking at the equation? 12. That's the y-intercept. That's where it's going to cross the y-axis. So I know I have to go at least up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So we've got A equals 1, B equals 8, C equals 12. So my y-intercept is 12. Okay. All right. What's my next step?
Well,
Axis of symmetry. Axis of symmetry. What formula do I use to find the axis of symmetry? Good. Negative b over 2a. All right. Well, b is 8, so we've got negative 8 over 2 times 12. I'm sorry, b to a, not c. Sorry, over 2 times 1, which equals negative 4. My axis of symmetry is x equals negative 4. Right? So we're going to make that line 1, 2, 3, 4. We're going to draw that line, sketch it as a dotted line because it's not actually part of the graph. It's just a tool that we're going to use to complete the graph. Okay. Now what? Yes, now we have to find the vertex. Good. And we plug it in. Okay, we've got negative 4, and I need to figure out the y. So y equals x squared plus 8x plus 12. So we have y equals negative 4 squared plus 8 times negative 4 plus 12. All right. That gives me positive 16 because negative 4 times negative 4 is positive 16 plus negative 32 plus 12. That gives me, let's see, 16 plus negative 32 is negative 16 plus 12, which is negative 4. So my vertex is the point negative 4, negative 4. So we're going to plot that point. 1, 2, 3, 4. There we are. Negative 4, negative 4. That's my vertex. Okay. At this point, I only have half of my graph. Half of the graph, it rhymes.
you want it for memory.
Yeah, it's symmetric, right? So fold it over.
-1.
So when I fold it over, I have to go 4 in that direction. So there's my 3 points. Now I can complete my graph. Make sure you remember to put arrows on the end. And we're done. Okay, not too bad, right?
Can you go back down a little bit?
We have to do it in a separate classroom.
Yes, there's another worksheet in Google Classroom. There are 4 problems. You need to show all of this work. If you simply sketch it, I will give you 0 points. You have to show this work. You must show this work, okay? So there's a worksheet in Google Classroom called Standard Form. Yes, sir. Both.
Can we like draw it online and then like have our equations like this?
If you take pictures of both.